All right, the first thing we need to talk about. Thank you. The first thing we need to talk about is on the 6-6 homework, the percent error homework, which I've now gone back and fixed. But question 5 had the wrong answer marked as the right answer. I had a lot going on. I went too fast. When you go too fast, you make mistakes, even adults. So this we're going to make as kind of like a freebie. If you haven't done this yet to 80%, you'll know the answer now once you walk out of here. But how do we calculate percent error? Not what is the percent error here, not what numbers do I divide here. How, in any situation, do I calculate percent error? And Ellie, since you weren't here, let's go with you.
You take the estimated value and you subtract the actual value, but you make it absolute value.
I love all the values.
And then you divide by the actual value.
Yeah, so I accidentally marked 50% as the answer. I'm going to tell you exactly what I did wrong. I did the first part Ellie told me. Find the difference between the estimate and the actual. That's 40. Then, how did I get the wrong answer? What'd I do, Andrew?
The 80 on the bottom.
I accidentally, in my quick not thinking through everything, because I saw car would cost and I thought that meant that was the actual. But you have to go back and say they estimated the car would cost $80 to fix. And sadly enough, this often happens. They call you back and they say, we're sorry to tell you, it's going to be more expensive than we thought. The actual was $120. And this is why I do all my own car work, if possible. This reduces to 1/3, which is the percent 33.3. Now, because... Chill. No, you did not get it wrong. Because, does anyone know that they've done their test up to a point that they'd be fine with me sharing it? Like they've done this assessment. Okay, Andrew, you're across the room. I can see you. I know there's lots of volunteers, so I appreciate that. But, so if I go to results, Andrew... Sorry, we're going to see everyone, but you guys aren't really that worried about it because most of you guys all have pretty much the same score. Andrew had that marked, and it would have told him that it was wrong. But now that I've changed it in the settings, it's going to give you the points. So even if it had told you that you got it wrong, if you go back and look at it now, it's going to tell you that you got it right. Well, I mean, if you marked 33.3, yeah.
I marked Felicity point for the first time, and I did 66.7 and then 15 because it kept saying it was wrong, but it still counted that as right.
Yeah, if you ever marked 33.3, then yes. But if you never marked it, because this is the right answer.
I did mark it.
I knew it. So since it's marked right, would it give you the percent for it? So if you had like 79, okay. So
Now it'll give you that percent.
yes. Yay.
Really, I'm not worried about most of you guys because there were 10 questions on that one. Which reminds me, sometimes I hand these out to everybody, and sometimes I just make it like up to you guys. Chapter 5, Progressing to Mastery, is right here for you to get at your leisure. AO, extensions, after class. If you need one, grab one. How does that then get turned in? It's the exact same as Chapter 4 was, so who remembers? Monica?
You write your name on it, everything, and then you turn it in.
You write your name on it, of course, you turn, but you don't just turn in the Progressing to Mastery. Sam?
Turn in your corrections.
You turn in the original assessment with the corrections to the problems that you had gotten wrong, which you can come do with me, you can do with your peers, you can do with your parents. You can ask me to post a video and I'll do it for you. Then what you have to do on your own is the Progressing to Mastery, which you can still get help on, but you need to make sure you understand the concepts. Then you staple them all together and turn it in. Now, those of you that are either not listening right now or don't care when you go to turn things in to think about, am I turning this in right? If all you do is turn me in the Progressing to Mastery, I'm going to give it right back to you and ask you to ask your peers what else needs turned in with it. Because I'm getting tired of repeating myself, especially since you can always go make me repeat myself via YouTube. So I'm getting very tired of putting my effort towards saying things that you should have already heard. Capiche? Sweet. So, any issues from yesterday's video lesson when I was not here? It was Micah Hudson. I have two different ones, but the like main one that will pop up is my math one. My other one that's like my personal account has like old marching band videos on it, but it's way less popular because I don't have very many views. So if you want to watch like the old marching band competitions that I was part of, actually I don't know if those are the ones I was in or those are the ones I recorded, but that's on my other channel. Whitney.
I just want to say that this one was like probably the easiest one in 6. It
Mm-hmm.
was really easy.
Mm-hmm. And that's also because you've already done enough practice. These skills just seem easy to you now. Like, that goes back to your background knowledge, right? Now that you have more background skills on decimal percent fraction work, it seems easy. But if I had given this to you, like the day we did 6-1, it would not have seemed that easy. So that's cool that you make that observation. Monica?
I got everything, and except for the very last question on the I just didn't I kind of knew how to get it, and after I saw how you did it, I kind of understood it. But if I got another problem like similar to this, I don't think I would, because it was confusing.
Yeah, so 3 friends go to lunch, right? And here's the problem with when you go to lunch with people or when you like go share something, they all like order appetizers or whatever, and they're like, well, I'll split the check. And if your families or whoever have ever split checks, sometimes you split it straight down the middle, sometimes you say, I'll take this item and you can take that item. So these 3 friends say, we'll just split it into thirds. And a third is approximately, which a lot of people use, 30%. But that's not true. That's 3/10, which is close, but it's not quite there. So if each of them pay 30%, that would be 30% times the 3 of them, which is only 90%. So if each of them paid 30%, would only be paying 90% of the bill, which is how you get put on like the wall of shame that says like these people left without paying their bill. So that's not good, right? You have to pay 100% of your bill, and normally you pay over that. Why would you pay over 100%? To tip, right? So we look here, and actually this gives a very easy answer to the part B. If I'm trying to pay 90%, my error is 10%. But we could also calculate it by saying each of these friends are trying to pay 30% of $37.50. So we would multiply and find out what each of them paid, and then I could find the difference amount, so that how much more or less do they need to pay. I could then subtract, or if I know they need to pay 10% more, that's 10% of the $37.50, which is just going to be $3.75, because that's 10% of the $37.50. So if they tried to leave, they'd still owe $3.75, and that's not really fair. And most servers do not make very much money, so if somebody shorts them on their bill, a lot of times the server has to pay for it, because somehow the boss says, like, well, that's your fault. It's not. A lot of servers get mistreated. Whitney?
I also put like that since there was 3 people that had to pay, it wasn't $3.75, so it was $1.25 per person.
Ah, you did each of them. So as long as you notated, it'd be like $1.25 per person, that'd be fine. So this $3.75 would be for the whole group, or like $3.75 in total extra that they need to pay. Evie?
In Scotland, their people, like their
Servers?
servers, they actually get paid really decent, so it's considered rude to give them tips because it's acting like they don't get paid enough.
Yeah.
So it's considered.
We talked about this
So,
in class.
the reason that people tip in America is it has become customary that you pay extra for how you think the service was. And the problem with this is some people think that if the service was bad, like my food took a long time, or like I didn't have ice in my drink, or something, like they think that's the server's fault.
No.
The server's not the person cooking your food. That server may have had one of the other servers call off that night, and they might be pulling double duty. Like they might be waiting extra tables. So some people will say, if my service was bad, I'm not going to tip. And that's really rude because most servers make about $3.25 an hour. $3 an hour for the insane amount of work the servers do. They do a lot of work. So you should always, most people say, tip a minimum of 10%, which in that situation would have been an extra $3.75. But if your service was good, you normally tip about 15%. And if your service was really good, you'll tip 20% or more. My mother-in-law, who like now can tip well and is fine with that, she like thinks back to the days of when, you know, and you guys will hopefully work some of these crappy jobs, not because I want you to have a crappy job, but because you can then appreciate those people that work those jobs. She will sometimes tip upwards of 30% if she thought the service was really good, because those people need the money. Those servers need that money. This goes back to like that article that we read about getting loans to try to move into somewhere nicer. Well, if that server can't get a loan from the bank, their only source of money is their job. Ellie?
My friend had people walk out on a $275 bill, and then in the same day, someone tipped her $20 and another waiter or waitress took it.
Jeez. Yeah, that's the trouble too, is when people leave money on the table, then some of the other staff, like that, some places do communal tips that all of the tips go together and then you divide them to everybody evenly. Yeah, right. And that's normally safe, but some people just like leave money like under the salt shaker or whatever, like just got to leave it on the table. Couple more and then we got to move on.
There was a restaurant that took the tips from their waitresses.
Yeah, and that's illegal. Some restaurants have gotten in really big trouble for that. But you are supposed to document credit card tips. You have to pay. This is the problem. This is why you should tip in cash if possible. Credit card tips get a percentage taken out of them because they're swiped on a credit card. All credit card transactions get about 2 to 3% taken by the credit card company, so that the credit card company makes some money, and that like you wonder, how does Chase or Visa or those companies make their money from you using a credit card? That's how. They get a percent of every purchase. Ozzy?
There's only one time I've ever been somewhere where we didn't tip a waiter, was when my grandma didn't want carrots and they brought her carrots. He took the carrots out with his hands.
Oh my gosh. Yeah,
That's the one time.
he should know not to do that.
That was not
Yeah.
bad.
Flynn, then we gotta move on.
I don't know, like, this reminds me of like that one movie where like that guy tips like the waitress at like that one restaurant, but like it's like a lot of money that like could pay off like college.
Yeah, some people, like, if they've got tons of money and they realize this server, you know, is in a hard situation,
Like,
they'll leave a lot. Do you remember what that
what's the
movie?
called again?
I can't remember. I know what you're talking about.
Yeah,
but-
like he gives her like, was it like $1 million or something?
Yeah, and like that has happened out in the world, and it's
it's
like
based
there
on-
are some really nice people. Last two, we got to move on. Elena?
We were at Bob Evans and there was this horrible waitress and it wasn't that like she gave us like, it wasn't that she like kept serving us the wrong thing or anything, but she did serve us the wrong thing. But then when we said she served the wrong thing, she said, ugh, and she like rolled her eyes and took it away, and then she was so sassy.
Yeah.
Wait, which Bob Evans? The one Sawmill?
Hey, doesn't matter. Andrew?
Me and my, there was this thing for school that I was thinking about, and I have this person that I go around with, and we usually eat out together. And there was this, we went to the Waffle House, and
Bless you.
the people there
Bless.
were like working really hard, and it was, I was thinking about them, and I asked if we could we tipped them like $100 or something.
Jeez, yeah, that's sweet.
They were working on like a Saturday on like a football day.
Yeah, crazy traffic and stuff. Sorry, we got to move on. If you guys have other stories, talk to me at lunch or whatever. I love hearing your stories about like math out in the real world and stuff. So, a ratio. We've been talking about ratios this whole time because a ratio is just a fancy way to talk about what? What is a ratio? Dom?
Isn't it like a division?
It's a division. It's the comparison between two numbers. So really, a ratio is the comparison, which then we end up dividing. So a ratio takes us to division. But what a ratio really is a relationship in which for every x of one unit, there are y of another. So we're just comparing two different values, and we would write that ratio in three different ways. You have three different options, which again sometimes makes things difficult. But the first way we normally see it is a verbal comparison. Let's pick two numbers.
7.
2 and 3.
27.
I heard 2 and then 7.
Yes.
27.
So let's use 2 and 7. So we would say 2 to 7. We could say 2 colon 7. Or we could do 2 over the 7 and write it set up like the horizontal or the vertical division. Now, oh, that pencil sharpener kind of sucks. Sorry, it's just mounted to the counter, so it's still there, but this is probably better. So if you guys ever need a pencil sharpener, in case I haven't announced that in this class, you can come up and grab it out of my drawer, just my center desk drawer here. This is also, if I ever have a sub here, there's like basic first aid supplies. That's where the staples and paper clips are. Just a bunch of random stuff. Glue, tape, things like that. So, if we then did this division, and this is why I'm glad that we, somebody said 7. That would lead us to that decimal. That decimal's really messy. And that's why we don't like the decimals really. We would just use my fraction. So a lot of times we leave a ratio in ratio form because it's simpler. So, when we have a ratio that we don't know part of. So let's say I'm going to give you, let's say you have a group, I'm going to give you half of this pizza.
Yay.
And you know that this pizza has 14 slices. So, right here, and a lot of you probably know this already, when we have a ratio equal to another ratio, and I'm a little bit too zoomed in here, we set them equal, and then we cross multiply to set up an equation, and then we'll be able to solve the equation. So let's say I tell you I'm going to give you half of the pizza. But that doesn't mean that I'm giving you 1 out of 2 slices, because hopefully we slice the pizza into more than 2 slices. That's all you got of this written down, bud? So you know the total of the pizza is 14 slices. It's a very large pizza, and you don't know how many you're going to get. Now, this is a really easy example. I know that. A lot of you already are like, but duh, 7. Write down the work that I write down. So on your homework, this makes sense. We cross multiply, so you're multiplying diagonal products. We cross multiply the other cross multiplication and get 1 times 14. So that then gives me 2x equals 14. Now, like we started doing briefly earlier this week, we can isolate a variable by looking at what connects it to its number and then undo that. So what connects x to its number right now? Sam?
Multiplication.
Multiplication. What's the inverse operation to multiplication? Go ahead.
Division.
Division. So I'm going to divide by 2 to get rid of the 2. And I have to do it on both sides. That then leads me to x being equal to 7. And if I plugged it back in, I could check and it would be true. Question, Jeremiah?
Why would you ever do the cross multiplication instead of just like doing it like normally, top like numerator to numerator and
Because
denominator?
sometimes the numbers are like really huge.
Ratio's the best math ever.
We studied some hard drives that we were making. If you've gotten to that homework, we're making hard drives and we're checking them. 3 of the hard drives out of 147 that we checked have a defect. Well, shoot, we just shipped out 2,000 hard drives. How many of those probably have defects? How do you go from 147 to 2,000?
Multiplying by some amount.
Some crazy number that's going to be a really awkward decimal.
Yeah.
So we could. We could figure out that value by, instead of asking what do I multiply by, I could actually divide to figure that out. And this would come out to be multiplication by, it's going to be, is it 6 something? Did you have it, Dom?
13.605.
Are you sure it's 13? Oh, yeah, okay.
13.6054422.
No, keep going. And you run out of screen, right?
It goes 4, 2, added there, but it goes 4, 4, 2, 1, 7, 6, 8, 7, 0, 7, 5.
Your screen goes backwards.
Oh, wow.
Whoa.
So then I would have to take this value and multiply the 3 by that to figure out this. This is convoluted.
Got it.
Instead, all you would need to do is cross multiply. You don't have to write this down. I was just showing an example because I got asked why are we doing this.
I have the answer.
3 times 2,000 would be 6,000. Then you would divide by the 147 and get your answer right here. So really, the way that you can think about doing the cross multiplication really easily is cross multiply the products that you can and divide by the value that is across from the x. So you cross multiply these and then divide by the 147. If that doesn't make sense to you yet, just do the whole process. What?
Like miniature smart boards.
So we were actually just discussing this morning. They have smart screens. It no longer has a projector. It is a screen, like that screen, that is touch capable. So we're debating how long until we try to get one of those. Write each ratio in all 3 ways. Sorry, I didn't give you a ton of space here, so I guess you could write your ratios for A off to the left and your ratios for B off to the right. Yeah.
In a gigantic touch screen monitor?
Yes. It's like a smart screen. Like it's made by Smart, the same company that makes these.
I'm in a tiny one like this big.
So like an iPad?
Pretty much.
iPad
Pretty
is
much.
for work.
Okay, so
I mean, but this is better.
bring it back.
M-pad.
What's the ratio of solid? What type of balls are these, by the way? What game would these go to? Don't say pool. Billiards is the proper way to say that.
Are you sure it's not baseball?
Yeah, I'm sure.
I think it's baseball.
So
It could be
they do actually have a soccer billiards place where you like the pool tables are, and you kick the balls instead of hitting them with like a cue stick. So yeah, it's pretty cool.
I would definitely.
I've got cards. I don't know why I'm not using these. Jeremiah!
Yeah.
Okay, sorry, Smith. I might as well just call you guys by your last names. Smith! How many solid colored billiard balls are up on the screen?
654.
What?
Try again.
If you probably timed up all the numbers.
4, right? We've got the 2, the 6, the 7, and the 4. So 4, 2. How many striped billiards balls are up there right now? Whitney? 5. We've got the 10, 11, 14, 12, and 15. 4 to 5, or we write 4:5, or 4/5. And if we wanted to talk about that as a rate, that wouldn't really make sense because this is not part compared to total. This is part compared to part. So that's why we would leave this in our ratio comparing solids to stripes, because when you play billiards,
You're either solids or stripes.
yeah, you're normally versus each other. So right now, this tells me that since the beginning of my ratio is the solids, and that number's less, right now whoever is solids is doing better.
Yes.
But the 8 ball is missing, so this is kind of weird since the 8 ball is missing, but don't worry about that, especially if you don't understand billiards.
Where's the 8 ball?
So now, even compared to odd. Set up your ratio.
Oh boy.
Do it on your own if you haven't done it yet. Even compared to odd. All right, Acadia, what do you got? Even compared to odd.
Well, you would add up. You wouldn't add them, but it would be
Count up, right?
yeah.
How many evens?
It's 6 to
Yeah.
Oh, sorry, could not hear. Then we do the colon, and then we show the fraction method.
Oh.
Any questions with what we're doing? Yeah.
Couldn't you simplify that?
Yeah. So we could say this becomes 2 to 1. Be careful, it's not 1/2, it's 2 to 1. But you would not make this 2 because you still want to compare evens compared to odds. So there are 2 evens for every 1 odd, or 6 evens for every 3 odd. So either way that you say it, it communicates the same message. Try the got it on your own. How many pins are left standing compared to the pins knocked down in all 3 ways that we write that? This actually goes directly back to the question you asked on squeegee about simplifying or reducing total fractions. So as we're working through this, I'm working with you, and hopefully this lesson brings all that back to your memory. Pins left standing. Anish, how many pins are left standing?
7.
There are 7. How many pins are knocked down?
3.
Because there are normally 10 pins total. So we write 7 to 3, or my next method would use the
7.
colon,
It's good for your
or 7 over 3.
What is
There are 7 pins left to knock down compared to the 3 that have already been knocked down.
Do you know what the colon is in your body, or what does it do? Because I always hear something like that. I don't know what it is.
I think it has to do with digestion. Like it processes nutrients and stuff.
What are these
That's
ones?
good for your colon.
Everyone talks about are these little circle things in there.
No idea.
I forgot what they're called. Tonsils. So what do they do?
Tonsils or adenoids?
I don't think they really do much because you can take them out and live just fine.
Well, you're a pet.
So, equivalent ratios
Yay.
is nothing more than a reduction of the fraction or a multiplication of the fraction. So if I want an equivalent ratio for 2 compared to 6, I could reduce that down to 1/3, or I could actually multiply it up down to 4/12. Because if I have 2 of something compared to 6 of something, it's the same as having 1 to 3, or it's the same as having 4 to 12. And we could keep doing this process for infinity. There are infinitely many equivalent fractions that all would reduce back to 1/3. So we are working at the pet shelter. If you've never volunteered at a pet shelter, it's a pretty good experience.
I have.
So we know that the ratio stays the same regardless of whether we're talking about treats, food bags, or food cans. So this ratio right here will be the same ratio that we find here and the same ratio that we find here. So what we can first set up is kitten compared to cat. So somewhere right there we're going to have kitten compared to cat. And the only value where I have both of them is my treats. So I set up, okay, kitten compared to cat. And I'm going to stack it because I feel like stacking is easier. You can set it up however you prefer. Then, what could 42 and 56 both divide by? Got a lot of people. Ellie, your hand is up. Or sorry, your card is up, I mean.
You can divide by 7.
Divide by 7, right? Which gives me an equivalent ratio of what? What's 42 divided by 7? 6. 56 divided by 7? 8, which actually that can then become 3/4. So I could have actually divided here by 14, but it's totally fine that we didn't. Now this is really nice because my denominator is the cat values and my numerator is the kitten values. So this is as far as I can reduce it is 3/4. But this right here, 6/8, helps me answer one of my questions. Julian?
You have 6 bags of kitty food.
I would have 6 bags of kitty food because that ratio has to stay consistent. Now we're going to need to solve a ratio. I'm going to use my reduced form 3/4 because the numbers are easier to work with. I'm going to set this equal to another ratio where I only know one part of it. Excuse me. Do I know the numerator or do I know the denominator? Ashley, what do you think? This 126, would that go in the numerator or the denominator? Numerator, right? Because that relates to the kitty. So then I choose some kind of variable. I'm going to say C for cat. Or whatever variable you choose doesn't really make a difference. Please write out this process. I'm running out of screen, so I'm going to kind of swoop over here to the left side. But when we cross multiply, we're going to multiply the 3 times the C and the 4 times the 126. So actually, I think I can keep working down. So if I do 3C equal to, and for us, I will sometimes skip steps. So what do you get? 4 times 126 is?
504.
504. We then, because these are multiplied by each other, have to divide. Or you can think through, I cross multiply the two values I can, and then I divide by the value remaining. So 504 divided by 3, what do you got, Dom?
168.
168. Yeah. Then if I plug in 168 here, 3 times 168 should also give me 504.
Yep.
My cross products should always be equal once I plug back in and check it. So if you ever want to check it, plug it back in and see that your cross products actually equal each other. Julian?
You could also just do 56 times 3.
Yeah.
Yeah. So if you recognize, there's always lots of right ways to get to Florida. I love that you guys identify these other ways. If you identify that this is just times 3, we could just do times 3,
Yeah.
but we wanted to solve using cross multiplication. So that's why I hope you wrote down this method. Any questions or comments? No?
I have another method to get the
Okay.
answer.
How else?
You can divide 126 by 6 to see how much goes within that, and multiply your answer.
Yeah,
by
that's
8.
kind of the same thing as the 42 to the 126. So yeah, always lots of ways that we can deal with these ratios. So, find an equivalent ratio with lesser terms. I want you to list as many as you can think of with lesser terms.
There's actually an infinite amount.
Well, lesser integer terms. We like to only use integers in my fraction.
Oh, so it's lower,
mean
like
lesser
lower.
terms?
Lesser terms. The numbers have to be smaller. Because you can find equivalent ratios with larger terms forever. You can keep multiplying, but you can only get so small. But we don't use decimals in a fraction. That's called a complex fraction. We don't like those. Not that we can't do it, but we don't like them. They're complicated.
Isn't there only one for this one?
If you would have
Yeah, it seems like there's only one.
Unless we use decimals.
Sometimes I like to be tricky. What's the only one that you can think of?
4/5.
4/5, right? How did you get there?
Divided by 3.
How'd you get there, Elena?
by dividing both 12 and 15 by 3.
So we divided by 3 on the top and divided by 3 on the bottom. Now, if we look at trying to divide by 2, because I can divide 12 by 2, it doesn't work for 15. If I try to divide by 3, it works. If I try to divide by 4, because 12 can divide by 4, it doesn't work for the 15. I can divide by 5, it doesn't work for the 12. So I go through these options, and what works for the denominator doesn't work for the numerator is not an option. So the division is a lot more rigid than the multiplication. If I wanted to find just any equivalent terms, I could then start with my lowest value and just start multiplying. So if I multiply by 2, I'd get 8/10. So wait a minute. Isn't this an equivalent fraction
Yes.
with lesser terms?
No.
So when I asked you to find every one that works, you got stuck right here because you let yourself get stuck.
No.
So if you were one of the people saying there's only one, I agree, there's only one we can reduce to, but then we can start multiplying up and get other values that still will sometimes have lesser terms. Now, other values that aren't lesser terms, well, we already did the times 3, because think about if we did times 3. So then if we did times 4, we'd get 16/20ths. If I did times 5, I'd get 20/25ths. If I did times 6, I'd get 24/30ths. And we could keep going like that forever.
That's not less.
I know. I started that sentence. If we ignore the lesser terms, we have infinitely many options. Any questions? Be careful when it asks you about lesser terms. Do not just think about the division. Divide down to lowest and then think about multiplying up. So, one of the main reasons that we use this whole equivalent fractions is dealing with unit rates. And we're going to get to unit rates here very quickly. I don't know if we'll get to it this week or next week. But unit rates are any time there's one of something in the denominator. But sometimes we then want to take that and manipulate it to not be a unit rate. So they're comparing 30 minutes out of an hour. So maybe you sleep 30 minutes out of every hour, like an animal does. Or maybe you're working out 30 minutes out of every hour and then you're swimming or something. So then we can switch units. It's no longer a unit rate, but we're getting to a simpler ratio, because to write a unitless ratio, your units have to match. So I would like you somewhere to notate that to write a unitless ratio, or you can highlight or whatever, your ratio must have the same unit of measure. So this is not a proper ratio because they do not have the same units. You have to have the same units so that you can write just the numbers to make the ratio. Any questions on that?
Oh, I thought it was 30 minutes per hour.
No. So that's like 30 minutes out of an hour.
It could be MPH, just like miles per hour.
Oh, yeah. So the sections in chapter 1 should be a little quicker because honestly, if Pearson had decided, we would have started with this. But we'll pick up here tomorrow. You should be able to do your homework just fine. So we'll pick up here tomorrow, and then we'll cover the rest of this and all of 1.2.